Hello and welcome to Keep Coding. In our last video, we saw how to create a queue data structure with generics. On the same video, I mentioned that that queue is not a Goroutine safe one. What I meant by that is that if you have multiple Goroutines running and trying to enqueue and dequeue at the same time on the same queue, then it will fail because of the race conditions. Because we are doing a lot of changes here, right? We are trying to change the references of front and back, then it can cause failures. Okay, so we are going to fix that in this video. Before that, we have to prove that this queue will fail when you are calling it from multiple go routines at the same time, because once you are able to prove that this won't work, then when you are making changes to the actual queue and making it go routine safe, then you'll be able to test and verify whether the queue is actually go routine safe now. So first we're going to make some changes here. I'm going to create a new function, add random to queue. Okay, so I'm going to add some random numbers to this queue. So I'm going to have a property named job number, because this function will run in a go routine, which means that multiple instances will be running at the same time. So I'm going to identify each one by a job number. Okay, and then we need the queue, which is going to be queue.queue of int, and then I'm going to have count. So I'm going to say how many items has to be added to the queue, and that many items will be added by this function. Okay, so the first one is that I'm going to say fmt.println job %d started job number. So this is just for a reference, and then I'm going to say job completed. So this will be helpful when we are seeing the output. So I'm going to put a defer so that it will happen at the end of the function. Okay, so now I'm going to have a for loop for I equal to 0, I less than count. It has to add using enqueue, and then it has to add a random number. Okay, this has to be printf. So yeah, so now we have a function to enqueue items, right? So now what you have to do is that we have to run it parallelly using goroutines. So I'm just removing this enqueue part, so I don't need any of these. Before I start, I have to add a wait group. So this is in sync dot wait group. I'll explain why I have this wait group a little later. So now what I'm going to do is that I'm going to have 5 instances of the goroutine running at the same time. So here I'm going to say that go func do a wait group dot add, to call it here. I'll explain what the wait group is, and then I'm calling the function. So here I have to pass the job queue ID. Okay, so which means that I need the job queue number here, so that I can pass from the I here and then use the same in this. Okay, so the second one is that I have to send a reference of the queue and then the count. So I'm going to say that 5000 items. Each goroutine is going to add 5000 items, and then 5 goroutines are going to run parallelly, which means that we expect 25,000 items to be added to the queue. Once all the 25,000 items are added, we are going to dequeue it one by one, and we're going to see if it is having enough number of items as we added. Okay, So I'm making this into an infinite loop so that we know. So here what I'm gonna do is that whenever something is dequeued and printed, I'm adding an I++. So here it is going to be printf %d. First I'm going to print the index and then the value. Okay, so that I can easily count whether 25,000 items are printing or not. Okay, so that's the way we are going to test it. So the wait group is needed here because all these 5 has to start at the same time and run at the same time, but we have to wait till all of them completes. Okay, for that we are going to add 1 to the wait group whenever a new go func is running, and actually this has to happen here before the go routine. Okay, and once 5 items are added to it, it will expect all the 5 items to complete, which means I have to mark it as completed whenever this go routine completes. Okay, so it will run, and then when this is completed running, then wg.done will be called, and then the wait group will wait till all the items complete execution. Now let's run this. See, it says job started, and then it says memory address nil or nil pointer dereference, because at the same time multiple go routines are running and something is failing because of the reference is not there in the queue. And will run again. Each time it might give a different output. Before that, I just want to add a new line here so that I can see it properly. Let's run this again. See, the queue had only 6,200 items while we expected 25,000 items. Each one has added 5,000 items, but then some of them are lost somewhere. This is the problem due to that the queue is not go routine safe, and this is not a guarantee. Each time you will get a different output. Sometimes it will be a nil pointer error, and then sometimes it can have lesser counts. So now to solve this, what we need is a mutex. Okay, it's not stack we are trying to change. We are trying to change the queue, and I don't want to change the same queue. So what I'm going to do is that I'm just going to copy the queue part into Goroutine-safe.go, and then it is going to be package queue, of course. Under that I'm having the same. Okay, but the type is going to be different. Here the type is going to be safe queue. Okay, so this is from safe queue and this is also from safe queue. Okay, so here we need a mutex sync dot. I'm going to use RWMutex because we have two kind of operations. NQ and DQ are actually changing the queue, whereas peak is just reading it. So multiple reads can happen at the same time. So it will be great if we can have an RWMutex which will allow the peaks to run parallelly, but it will not allow an NQ or DQ to run parallelly, or an NQ or peak to run parallelly. Okay, so now I have to use locking mechanism here. So what I'm going to do is that I'm going to say that q.mutex.lock. I'm using lock here because I'm doing a write process here, and then I'm going to say defer q.mutex mutex dot unlock. So whenever this function completes its execution, this unlock will happen. Okay, so again I need the same with dequeue, because it is also a write lock and not a read lock. But in the case of peak, it is going to be a read lock. Okay, so I'm using r lock and r unlock here. Okay, so that's it. Go makes it super simple to make this into a safe queue now, and then I have to change this into a safe queue. Okay, and which means this is also expecting a safe queue now. So now let's run this again. See, so we got all the 25,000 items. It started from 0 and ended with 24999. And so it is safely added all the items and safely dequeued all the items without any issue. Okay, and that is Goroutine safe queue now. You can go and check the GitHub handle, which I'll add the URL below. So this is the third video of this series. I'll come up with one more data structure. If you don't want to miss it, please subscribe to the channel, and you can share the feedback below in the comments. Thank you.